Hey guys, this is Christopher talking. Welcome back to my channel. Today I'll be talking about calorimetry. So before we start off, we need to know what the formula is, which is the delta T H equals the M multiplied by C multiplied by delta T. And delta H, which is stands for the heat in joules, M stands for the mass in the grams, C stands for the specific heat capacity, and delta T, lastly, we have the change in temperature in Celsius. And also another thing, the constant value for H2O, which is the 4.18 joules per mole. Now we're gonna get to a couple of practices in order for us to get a better understanding. So for the first question, it's asking you about the molar heat of a combustion of the reaction. So first thing first, since we already know the formula, delta H equals to M multiplied by C multiplied by delta T. Here we can have the QH2O equals to MH2O multiplied by CH2O and multiplied by delta TH2O. And this gets us a 451,440 joules. But after we know this value in joules, we need to convert it to kilojoules, which is 451.44 kilojoules. After this step, we need to convert from Q reaction into negative QH2O. So this gets us right away negative 451.44 kilojoules. And after this step, we're not done yet. We need to use the H compound equals the Q compound over molar compounds formula, which is negative 451.44 kilojoules over 0.285 moles. And where we have the 0.285 moles is from the combustion of the reaction here, compound. So this gets lastly negative 1,584 kilojoules per mole. And that's the answer for the first question. Next question, second one. We're asked to find out the molar mass of the compound. So we can use the same formula, QH2O equals to MH2O multiplied by CH2O and multiply lastly delta TH2O. This gets us a 100,320 joules. It's basically the first two steps are the same thing for question 1 or 2. So we need to just copy down the formula, the same exact step. So here, after we figure out the joules, we need to convert to the kilojoules, which gets the 100.32 kilojoules. After this step, the Q reactions equals to negative QH2O. This gets us a negative 100.32 kilojoules. And H compound equals to the Q compound over delta H moles compound, which gives us a negative 100.32 kilojoules over 1,160 moles per kilojoules. And if you divide it all together, it gets us a negative 0.086 mole. But in this case, we have we need to know the molar mass for the compound. We need to use the 62.3 grams, which is where we're getting from here, and we're divided by 0.086, and this gets us 724.418 grams per mole, and that's the solution for the second question. For the third question, we're asked about the increase in temperature. So we know the formula that we have right here. Since we're given with the MH2O, CH2O, we're figuring out the delta TH2O. So in this case, we are given 0.875 moles, and we can multiply by 1,350 kilojoules per mole. And this gets us a 1,181.25 kilojoules. And we need to convert from kilojoules to joules. This gets us a 118125 joules. And after this step, we can use the Q reaction equals to negative QH2O. This gets us a negative 118125 joules. So after this step, this is where it kind of different from the first two examples. So we need to use the delta T H2O equals to the H reaction multiplied by mole, and H2O and over M H2O multiplied by CH2O. So in other words, we can write as a negative 118.125 joules divided by 170 milligrams. So we're basically converting 1.7 liters into milliliters. So it gives 170 milliliters of H2O and multiplied by 4.18 joules per grams. And this lastly gets us a negative 166.23 in Celsius. That would be the solution for the three practice questions that we just solved, including the formula that we just talked about. This covers the entire topic for the calorimetry. Thank you guys for watching. Please comment, like, and subscribe. I'll hope and see you next time.